So this is our chapter where we're going to do some graphing. Now, we'll be graphing in what's called the rectangular coordinate system. It's also called the Cartesian coordinate system. I'll explain that in a minute. I noticed that in several students' comments, they mentioned that graphing was sometimes a problem. So we'll try to take our time and go through them and hopefully explain things so it'll go a little better. At least it means that you've had some experience with graphing, which will greatly help. Now, there's different types of graphs and different things that we graph. We're going to talk about graphing in terms of two variables, though, x and y. That's what this chapter is going to be focused on. When we want to graph just on a number line, that would be more of just like one value. That'd be in on a line, like you could say, what is x equals 3, and graph that 1, 2, 3 like that. But this isn't what we're doing. I mean, that is graphing, but we're going to be graphing in two space. So on a plane, okay? So think of a plane as a piece of paper. Plane as in P-L-A-N-E. Okay? All right. So here's an example of a piece of, graph paper, I guess. And on the exams, I'll provide the grid for you. I like this one. It goes 10 in each direction, and that usually is enough for our purposes. You can always change the values of the units, if you want to count by tens or twos or something like that. Generally, I avoid that, though, just for consistency in our graphs. But we'll see. We may have some graphs where we have to do such things. Okay. So this is an example then of what we call the rectangular coordinate system, or it's also called the Cartesian coordinate system. So we're not graphing on a number line. We're graphing in this plane. So think of it as a flat space, a piece of paper, but with two dimensions to it. We have what we call the x-axis, axis, and the y-axis. So the x-axis is the horizontal one, the y-axis is the vertical one. Oh, I was going to tell you, Cartesian, it's named after a French mathematician, and his name is René Descartes. Okay, so that's where we get that. But you'll see it called the rectangular coordinate system. Okay, so we have two axes. That's the plural of axis. So you have an x-axis going horizontally and a y-axis going vertically. Where they intersect, right here, that point is called the origin. And the coordinates for that point are 0, 0. So that's where things are starting. That's where you're counting. Now the x-axis works like a number. Number line, we're counting 1, 2, 3, each of those spaces. I don't usually put the numbers in because it gets really messy. And then in the other direction, we're going -1, -2, -3, like that, so on and so forth. Okay, so the x-axis is like a number line with both positive and negative values. Positive to the right of the origin and negative to the left of the origin. The y-axis, I guess you could think of it like a thermometer, and you're counting up in the positive direction. You have positive numbers, and then down, you're counting negative. Okay? So that's the x-axis and the y-axis. Let's see what else. Oh, so together these two axes form what are called quadrants, and there's 4 quadrants. This is quadrant 1. We label them with Roman numerals. Quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So it goes counterclockwise. Okay? So if I have a point, what's called an ordered pair, something like 3, 4, then I would graph that. I would count, this is the x coordinate, and this is called the y coordinate. So the first one is the x-coordinate, and the second one is the y-coordinate. And they're separated with a comma, and we have parentheses to indicate that it's an ordered pair. If I wanted to graph that, I would simply count from the origin. I'd go 3 units to the right and 4 units up. Now, we don't normally draw those lines because they're in our way, but that would be the point. Now, points are often labeled with a capital letter, so we could call this point A. And sometimes we graph a lot of points and we don't label them, we just graph the points. And there are different reasons for that. Okay, so let's do another ordered pair. Let's graph -3, 6. So that means I'm going -3 along the x-axis, and then I'm going to go up 6. So right here, we're going to call that point B, and that would be point B. Okay? So I'm going 3 to the left, and then I'm going 6 up. That point B is in quadrant 2. All right, and then let's have another point, C. Let's have that be 6, -3. Well, this means that it's going 6 to the right, so 6 along the x-axis, 3, 4, 5, 6, and then down 3, 1, 2, 3. So it'd be right there, and that would be point C. Notice that B and C, they have the same numbers, but they're in a different order, and it makes a difference where your point is. That's why they're called ordered pairs, because the order matters. My point C is in quadrant 4. My point B was in quadrant 2. Okay, so let's not leave quadrant 3 out. Let's do one more. Let's see. -2, -5. So I would go -2 on the x-axis and then down 5, which I think is right there. And that's going to be D. Okay, and that would be in quadrant 3. Now, sometimes we have points that don't lie on a quadrant. So some of you might be thinking, hey, what if we have a 0 involved? So let's say we have 0, 7. Well, then 0 means you're not moving on the x-axis. You stay at the origin, but we want to go up 7. So it would be 4, 5, 6, 7. Be right there. That would be point E. And then we'll just do one more here. Let's say we have F as -10, 0. Okay, so then I'm going -10 on the x-axis, but 0 up and down, and so it's that point right there, F. Okay, now you might be asking, well, what quadrant is point E in? Well, it's not in a quadrant. We say it lies on the y-axis. And what about point F? We say it lies on the x-axis. Nope, this video is really long. Okay, so I have this another grid for you to use, but I'm going to use it on the next problem. But you can find graph paper like online. You can just type in graph paper and you'll get grids and stuff like that. Or you can purchase graph paper at a store. You probably really don't need to do that. When we don't have graph paper, we just make our own little grid system and we just count, you know, as best we can. The more accurate we are, the better our graphs, but a lot of times we have to do just kind of a quick little graph, and so we do something like that. There are arrows at the end to show that they continue. You'll notice my graph paper doesn't have those arrows, but you could put them in. It's understood that they're there. Okay? I'm going to stop this.